Hello, and welcome to the second webinar of a series on the topic Roadway Designer for Power Geopack. This webinar will focus on point controls and parametric constraints in Roadway Designer. My name is Kathy Kassar with MDOT Engineering Support Services. The future webinars in this series on Roadway Designer will cover superelevation, driveways and ditches, template transitions, intersections and gores, and creating surfaces and plotted cross-sections. Before attempting to set up a corridor, it is necessary to know how to import the DDB, TIN, geometry, and plan view graphics into Corridor Modeler. We are going to be focusing on Roadway Designer itself in this series and not the importing process. However, if you are looking for some tips and tricks on importing graphics in Corridor Modeler, please see Part 1 of the existing template series. It is also necessary to know how to build a template. Please see the previous webinars on building the proposed template for Roadway Designer for more information on how to properly construct a project template. What you should have before you begin to work with Corridor Modeler and Roadway Designer are the following: a Geopack PRJ file created and opened, a working alignment definition defined and in use, a Corridor Modeler RDP or batch load file created and loaded, imported horizontal and vertical geometry and plan view graphics, and lastly, a project template created. Parametric constraints. Once again, parametric constraints are labels that you assign to various component points or values in the template that can be used as redefinable variables in Roadway Designer. They need to be defined in the template to be available in Roadway Designer. They may be applied to any type of constraint, however, most commonly they are used for depth, slope, and width. They are not recommended for any element that will need to follow geometry, plan view graphics, or be assigned superelevation, such as the edges of pavement. It is also not recommended that you spend a lot of time creating an extensive list of parametric constraints on side slopes. There are easier ways to achieve the same results other than typing in a lot of stations and slopes. See Part 6 of the proposed template series for more information on setting parametric constraints. Once the parametric constraints have been defined, they can be accessed through the Tools Parametric Constraints dialog in Roadway Designer. Point controls. Point controls are the most powerful tool in Roadway Designer. They allow the manipulation of any point on a template regardless of any other constraint, definition, or rule. They are useful in assigning superelevation, controlling corridor connections at intersections and gores, following alternate geometry such as independent ditches and intersection radii, or manipulating null points to activate display rules. It is possible to assign 3 different types of point controls or modes of control, either the horizontal, vertical, or both horizontal and vertical, to any point in a template. There are different options available depending on which mode is selected. If contradictory point controls are assigned, such as 2 different definitions assigned to the same point in an overlapping station range, the point control definition will not function and the name will turn orange. The point controls will not work properly until the overlap or contradiction is resolved. In some cases, contradictory assignments can be resolved by adding priorities to the assigned point controls. It is also possible to set point controls to be a secondary alignment. As stated before, Roadway Designer models perpendicular to the geometry to which it is assigned. When a point control is assigned to be a secondary alignment, it instructs Roadway Designer to use that alignment as a control alignment, and will model everything after it intersects with that alignment as perpendicular to the secondary alignment. This is especially handy in intersections, gores, and boulevards, where one template is used for the entire roadway. How to assign them. Point controls can be assigned in the Roadway Designer dialog through either the menu, Corridor Point Controls, or the Point Control button on the main dialog. To assign a point control, select the point, mode, station limits, control alignment, or alignments in the case of both the horizontal and vertical, offsets and secondary alignments as necessary, and add the point. These point controls can be disabled without deleting them by clicking the enabled options in the dialog. As with any dialog in Roadway Designer, using the Shift left click together will allow the ability to pick a station from the plan view. When to assign. Once again, point controls are the most powerful tool in Roadway Designer. They allow the manipulation of any point on a template regardless of any other constraint, definition, or rule. They are best used for superelevation, complex transitions to other corridors, independent ditches, intersections, and manipulating null points for display rules. Display clues. Once a display rule has been assigned, The program provides some clues to when it is actually active. So you can see when it is active at a particular station because the point will have a purple box around it in the cross-section view. You will also see this highlight in the cross-section view if you deselect the display rule itself. Let's step out to the software and take a look at these concepts and steps. Alright, so once again, this is the dataset we've been working with, and this is what we're going to continue working with in this Roadway Designer in the series of webinars for Roadway Designer. Just to kind of, again, remind you, we're going to be looking eventually at this intersection for intersection modeling. We've got our bike path, we've got edges of pavement, curb line at the beginning, and as we get into it, we've also got some islands and some pavement back in a parking lot, as well as a shoulder section with curb and gutter. Of course, in the last webinar, if you remember, we also set our project so that we had 4 decimal places set up for the distance under our user settings. Here we had 4 decimal places on the accuracy in our project. Looking back at the template, if you remember, we're using proposed template 7. So if you have these in your default template library, you will have these available to you. Looking at the active template, we do see we have several parametric constraints already been assigned. Most of them have to do with either the depth of the material or in some cases the actual width of material. For the slopes for the end conditions, we've assigned it by width, as well as some slopes for things like our subbase. So these have again been predefined in our template as parametric constraints that we'll be able to access in Roadway Designer. Again, see the parametric constraints, the part 6 of the proposed template series for more information on how you would define these parametric constraints. Taking a look at the Roadway Designer dialog, again, we have set up our corridor. We set up our corridor at the last webinar, part 1 of this series, and again, that's going to be called Road 1. We set our alignments and our station range. We've also set our template, again to be proposed template 7. We did our interval at 10 feet, and it is synced with the library. To look at parametric constraints first, again, that can be reached through the Tools Parametric Constraints dialog, and we come up with this list. This is the same list that we had available to us in the template library. You can see there are many different depths, and there's just a few widths. Most of them is depth. So in the case of this, we're going to look at the leveling depth. Right now it is set to a depth of 2 inches, and I'm going to go ahead and change those across the project to 6, and you'll see that it has moved that leveling depth. As I move along the project and we get into the shouldered section, you'll see that in the shoulder we have something that looks a little bit off. So I'm missing a parametric constraint. So under the Tools Parametric Constraints, we're also going to have to look at the shoulder depth of the leveling course, and we'll change that again to 6 inches, and I'll add that in. And you'll see that has corrected that. So as you see, the parametric constraints work very, very well when you want to change an overall depth across your whole project. Again, I wouldn't be assigning them for things like the width of anything that's going to be driven with a Plan View graphic, but they're excellent when you want to change an overall width or depth, a depth of anything that is within your project. Definitely depths are great. If you have something that you are doing that is not driven by a Plan View graphic, such as your aggregate shoulder width. I typically don't do a Plan View graphic for the aggregate shoulder. That pretty much stays constant, but I could add that width in here so that I would change my aggregate shoulder width based on something I needed. If it needed a widen for some reason, maybe for a guardrail, and I didn't want to use a Plan View graphic, I could go ahead and assign those station stop and start values and the stop and start width, and I could change my aggregate shoulder width. Alright, again, same with the point control menu. We'll see if you click off the enabled button, you can leave the definition in place and remove it from the template in Roadway Designer from what's actually active. Again, this is not changing the template library. This is only changing what is active within Roadway Designer. And again, if you were to process your model under the Tools options, and you turned off your external control points, even if you had parametric constraints or point controls, remember, if you turn this checkbox off, it will ignore any parametric constraint or point control that you have set. As I've stated before, what you really don't want to do is have a bunch of slopes in here for things like your ditches or your slopes that are going to be tying here to your active ground. For your end condition slopes, you don't want to have a giant list of a bunch of end condition slopes, primarily because it just gets to be difficult to manage if you're constantly adding in and changing your slopes. I wouldn't even recommend using them for things like your subgrade. If you're going to do anything with a slope on your subgrade layer in super elevation, I would recommend that you do that with a super elevation control line. So primarily your parametric constraints should be used for things that you're not going to drive with either super elevation or planned geographic. So things like your depths are ideal to be used in a parametric constraint. Again, you'll see this again in the point controls. If I have an overlapping station range, so in this case I've done the whole length. Now if I come in and I do one that's not going to go the whole length, and I'll just put it at 80, and I create basically a contradiction, and I'll hit add, and you'll see that I get the names turn orange. And what that means is there's a contradiction between your definitions. You've overlapped somehow the same point or the same parametric constraint with two different definitions, and it doesn't know which one it wants you to use. So it won't work correctly until you either disable one or you delete one and remove that contradiction. Okay, so say that we wanted to make a change in the depth that was basically not going to be for the entire station range. So we only want to change that depth from one section to another, but we need to provide a transition for that. Typically you don't have a shear drop-off, but you could. But in this case we're going to say that we're going to transition the pavement leveling depth over a distance of 50 feet. So we want to make sure that we don't have, again, those overlaps. So we're going to start off at, I'm going to pick the pavement depth, and it will put it back to the default depth value, and we're going to say we're going to transition those 6 inches over a location or station range of 50 feet. And we'll hit add, and you'll see of course that it does turn orange when I do that, because right now I still have that overlap. And then the original entry, I'm going to change that from 51 to 0 to 51. And I'll hit change, and you'll see that we remove that overlap. So what that does is it provides that transition of 50 feet to make the depth change from the 2 inches to the 6 inches. And this is the type of thing you would need to do if you were transitioning maybe your shoulder or any other parametric constraint. You would need to provide the station range in which the transition occurs, and then the station range in which the value is the new value. And then if you were going to transition back out, you would also need to give it that transition. You can, like I said, do a shear face drop off and just make one to the next. But in most cases, you're going to have a transition. That's basically what you need to know to assign a parametric constraint. Again, they are variables, they are redefinable variables, and they are only available to you if you assign them through the template library. To look at point controls, again, you can reach those through corridor, point controls, or here on the pick list, the third button over as point controls. With a point control, you have a lot of flexibility. These are, as I said, the strongest, most powerful tool that you're going to have in Roadway Designer. To look at this dialog, again, you can give it a description if you want, a control description to tell you what it is, what exactly you're trying to do. It's not necessary. It can be helpful. As far as the point list, these are all of the points that you have defined in your template. That is the active template currently loaded. Okay, so this is the entire list of points. That's every point in the template. If you need to pick a particular point, if you hit the radio button, you can come out and select any point in the template. And you'll see that it has selected that point. From there, you're allowed to select 3 different modes. Mode meaning that these are the ways in which you want it to assert some control. Whether you just want to look at it horizontally, whether you want to look at it only vertically, or whether you want to consider both the horizontal and vertical adjustments or methods of adjusting that point with the point control. If you select horizontal as your mode, again, you can look at it, look at an alignment, a feature if it was within a surface, a style or a particular drafting style, or a corridor point, meaning a point that's in another corridor within the same Roadway Designer file. These are the 4 different options that you have to pick between if you want to do a horizontal point control. Alright, with a horizontal point control, you typically will assign either a start and stop offset based on a particular station range, or a constant offset if you want to do a null point and you want to activate a null point that may not be currently activated with a style constraint. Okay, and now remember, this too will override a style constraint. So even if you have one that's currently turning something on or in use and you just want to see what it's like to turn it off, you can go in here, select the null point, which is why in my names I always call my null points find. It groups them all together, makes them easy to locate. I know those are all null points. So in this giant list of all these names, it's easy for me to identify what my null points are. It's kind of why I always do a find or a seek in my null point name. So I can turn off or turn on any of my display rules by putting a point control on a null point. Switching over to the vertical, you'll see that I get 3 more options. One being super elevation, and then the other 2 are based on elevation and either the elevation difference or an elevation grade. With super elevation, that will get assigned automatically when you run the wizard based on your edges of pavement and your crown point. However, you can manually assign super elevation, which we'll see for things like our shoulders, for rollovers, and as well as the subgrade in our shoulders in order to control which direction that the subgrade will slope or the degree in which the subgrade needs to slope. So that is only available in the vertical mode. Looking at the both mode, you'll see that my secondary alignment becomes active and I'm back down to just 4 choices. Alright, now with the secondary alignment, as I said in the beginning, a secondary alignment is something that you would place on any other control alignment that you want Roadway Designer to model off of, perpendicular. So in the case of a radius going around an intersection, once it would reach that radius edge of pavement, it would then travel perpendicular from then on. So that would allow you to build a curb line that is not tapered. It would build the entire curb and the correct width of the curb going around a corner. Or in the case of maybe a gore where you want it to model perpendicular once you reach the gore, so that you get a solid component instead of one that's maybe tapering. It all depends on how you want it to model and how you want the triangles and the surface features to look once it's completed. Secondary alignments are also very handy, as I said, for boulevards. So if you create a template that has both, say, both right and left side pavements, whether it's northbound and southbound or eastbound and westbound roadways, side by side in one template with your median ditch or your median barrier in one template, in order to create your super elevation for the second alignment or the one that is not what you're using as your primary alignment that you built your corridor off of, you would then select a secondary alignment for everything having to do with the second roadway. So this secondary alignment function is very powerful. Again, with priority, it's very similar to our end condition priorities. So if you have several different point controls on the same point and you want one to override the other, you don't want to have those conflicts, there are times when you can correct those conflicts, basically giving it an if-then statement by changing the priorities that are assigned to any given point control. Alright, so looking again at our template, we see that you notice you've got these green boxes. Alright, as with point controls, those green boxes actually give you an indicator. What they mean is that you have a parametric constraint defined for those points. So this dialog actually gives you a number of different indicators, and I turned them off and you'll see those green boxes disappeared. If I set a point control, and I'll expand this out, if I set a point control for this slope, and I want to give it a horizontal offset distance, and we're going to say I want that to be offset, we'll go from the alignment, I'll just put something in there, 60 feet. And I'll do an add. And you'll see that it has moved, and I'll close this for a minute, and you'll see that it is now out at that 60 foot. That's not exactly ideal, obviously, because it's not touching ground. But you get the idea with the point control, that if you assign it, and you'll see that now it has a purple box around it, and that's the whole point. If you select it, you'll see the point highlights, you get it white, and you'll see that it has a purple box around that point, and that indicates that there is a point control active for that particular point. And I'll go ahead and delete that since it's not necessary. Alright, this project doesn't have a whole lot of things that need to have point control set. There is, of course, a tie line. Let me close this down. That needs to be set out here on the outside edge for the side slope conditions. So what we'll do is we'll take a look at how you would set point control for that tie line. And in this case, I'm going to go ahead and pick my slope, and I want it to touch that tie line. So I'll hit add, and you'll now see that it has moved and it has highlighted that line. Of course, that's not the only place that point actually exists. In the next webinar, we're going to look at superelevation a bit, and just to kind of give you a quick preview, that's going to include importing our superelevation tables and then setting up the various ends and then editing our superelevation in order to get these control lines and the various control lines that would be needed for our shoulder transitions. So that will be covered again in the next webinar, so that we can see again how these point controls for superelevation become assigned. So we will be going over this dialog, the superelevation mode down here in this dialog, and then how you would go about creating these control lines and the functions and tools available to you while in the superelevation mode. That was a quick look at point controls and parametric constraints in Roadway Designer. For some hands-on training for MDOT staff and those with access to Bentley Learn, try the course Road Fundamentals using Geopack, which will cover many of the topics that we went over in this webinar. There is also some supplementary training material available in ProjectWise. MDOT staff, please email the MDOT Powered Geopack support email address if you need help locating it. This concludes the webinar part 2 of the Roadway Designer series. Thank you.